Hi, in this video, we are going to look at a complex numbers problem, which is a little geometrical in nature. So let's look at the problem statement. Let Z1, Z2, Z3 be the vertices, be the coordinates of the vertices ABC of triangle ABC. Now, they have said that if W1 is equal to Z1 minus Z2, W2 is equal to Z3 minus Z2, and angle A is equal to 90 degree. Then which of the following options are correct? Option A is real part of W2 by W1 is equal to 1. Option B is real part of W1 into W2 conjugate is equal to mod of W1 square. Option C is real part of W1 into W2 conjugate is mod of W2 square. And option D is real part of W1 by W2 is equal to 1. And we have to figure out which are the options which are correct. And this can be a multi-correct question, right? Okay, so in order to do this problem, first you should draw a diagram. So let's say we have a diagram like this. It's a right angle triangle with angle 90 degree at A. So let's label it like this ABC. And this is my Z1, this is my Z2, and this is my Z3, right? This angle is 90 degree. Now think about it. Z1 minus Z2 is basically this side, right? This side is Z1 minus Z2. So we can call this side length as mod of W1 is equal to mod of Z1 minus Z2, right? Z3 minus Z2. If you think about that, Z3 minus Z2 would be this side, right? So this becomes your mod of W2 is equal to mod of Z3 minus Z2. Mod of two complex numbers, the difference between them is basically the distance between the complex numbers. So here BC represents mod W2 or mod of Z3 minus Z2. AB represents this. And obviously AC, if you think about AC, AC is Z1 minus Z3 mod. So actually if you calculate W1 minus W2, that would be what? Z1 minus Z2 minus Z3 plus Z2. So that will be Z1 minus Z3, right? Because Z2 and Z2 will get cancelled. So W1 minus W2 is equal to Z1 minus Z3. So this side, AC side is mod of W1 minus W2, right? So we know all the side lengths in terms of W's. One of them is W1, one of them is W2 modulus, and one of them is modulus of W1 minus W2, right? Now, what we will do is figure out how to do rotation here and use the fact that this is 90 degree, right? If this is 90 degree, by rotation theorem, this angle is 90 degrees. So I'll write Z3 minus Z1 by Z2 minus Z1 is equal to mod of Z3 minus Z1 by mod of Z2 minus Z1 e power I pi by 2, right? This is rotation theorem applied to this angle. Always when you do rotation theorem, you have to write the more anti-clockwise side first. So notice that this side AC is in the more anti-clockwise sense, right? So I'm writing Z3 minus Z1 first and dividing it by Z2 minus Z1, which is the less anti-clockwise side. And that is equal to this, right? This complex number would be its modulus, and the angle argument of this complex number is pi by 2, right? Okay, so now e power I pi by 2 is simply I. So you have mod of Z3 minus Z1 by mod of Z2 minus Z1 times I is Z3 minus Z1 by Z2 minus Z1, right? This result is there, which tells us that this angle is 90 degree. Now, if you understand here, Z3 minus Z1 is simply W2 minus W1. right? And Z2 minus Z1 is basically minus of W1. So I will do this in the next screen now. So this is my situation. A, B, C, Z3, Z1, Z2. And this angle is 90 degree. I have gotten Z3 minus Z1 by Z2 minus Z1 is equal to mod of Z3 minus Z1 by mod of Z2 minus Z1 e power I pi by 2, which is basically Z3 minus Z1 by mod of Z2 minus Z1 multiplied by I. And we know from the question itself that W1 was Z1 minus Z2, W2 was Z3 minus Z2. So clearly, W2 minus Z W1 will be Z3 minus Z1, right? So here Z3 minus Z1 can be written as W2 minus W1, and Z2 minus Z1 is basically minus W1, right? So we are getting this is equal to, this part is mod of W2 minus W1 divided by mod of Z2 minus Z1 is simply mod of minus W1, right? I. So here what I get is W1 minus W2 by W1 is equal to mod of W2 minus W1 by mod of W1, because minus 1 has mod 1 into I, right? Once we get this result here, I will be able to easily find out the real part. So think about it. This number can be simplified as 1 minus W2 by W1 is equal to, this is a real number, ratio of two moduluses is real times I. So this complex number is purely imaginary. Think about it, 1 minus W2 by W1 complex number is some real number times I. So it is purely imaginary, right? So we can say that the real part of 1 minus W2 by W1 is equal to 0 because it is purely imaginary. So we can say that real part of this is 1 minus real part of W2 by W1, and that will be equal to 0. So therefore we get real part of W2 by W1 is equal to 1. So that finishes off one part of the problem, and that was giving us the option A. Option A is correct and D is incorrect, right? So simple rotation theorem and using the information that they have given in the problem gives us this condition. And once you have this condition, you can easily figure out that this is a purely imaginary number. So real part of W2 by W1 is 1, right? If you are confused about rotation theorem, there are several videos on the channel which describe it in greater detail. Go through my channel, search for complex numbers, geometrical properties. You will get detailed explanation of all of this. So I have used this to solve part of the problem. Now, what about the other part? In the other part, we had to figure out what is real part of W1 into W2 conjugate, right? So I'll rub off this part here and I'll try to do the next part of the problem. So let's think about that one. So I have to find out the real part of W1 times W2 conjugate. So two options are like this. Find the real part of W1 times W2 conjugate, right? So when I do real part of this, I can also see that this is basically real part of W1, and W2 conjugate can be written as W2 modulus square divided by W2, right? So it is real part of W1 by W2 multiplied by modulus of W2 square. So obviously modulus of W2 square is a real number. So it is modulus of W2 square times the real part of W1 by W2, right? This is what I need to find. Now remember, we have just now proved that 1 minus, we just now got that 1 minus W2 by W1 was modulus of W2 minus W1 by modulus of W1 times I, right? This we have gotten just now. So from here, we can say that W2 by W1 is equal to 1 minus mod of W2 minus W1 by mod of W1 times I, right? Why am I focusing on this right now? Because ultimately I have to find real part of W1 by W2, and here I already got a condition on W2 by W1. So I got the complex number which is W2 by W1, right? Now think about it. We noted earlier that this side length was how much? Z3 minus Z2 modulus is mod W2, right? And what was this side length? This side length was mod of Z1 minus Z2, so this was mod of Z1, right? And this side length Z3 minus Z1 was basically mod of W2 minus W1, right? Correct. So here what I have is, notice here the ratio of mod of W2 by W1 divided by mod of W1. So isn't that the ratio of two sides of this triangle? So this is the perpendicular, that is mod of W2 by W1, and this is mod W1 is this side, right? So it is basically perpendicular by base. So I can think of this angle as theta. And if this angle is theta, I know tan theta is equal to mod of W2 minus W1 by mod of W1. That is obvious from the figure, from the right angle triangle. So I can write this as 1 minus I tan theta, right? And I have to find the reciprocal W1 by W2, which will be 1 by 1 minus I tan theta. And let's simplify this complex number a little bit. You can multiply by the conjugate, you get 1 plus I tan theta divided by 1 minus I square tan square theta. So that will become what? 1 plus I tan theta divided by 1 plus tan square theta, because I square is minus 1. So that becomes sec square theta. So you have 1 by sec square theta or cos square theta plus I times tan theta by sec square theta. Tan theta by sec square theta is basically sine theta into cos theta. So I have gotten W1 by W2 complex number, and I have written it like this in terms of theta, which was an angle of this triangle. And I've gotten it as cos square theta plus I sine theta cos theta. So now the problem is really easy because I just have to find the real part of this complex number, right? So real part of this complex number is clearly from here. We can see it is cos square theta. And cos square theta times mod of W2 square, right? Notice mod of W2 is the hypotenuse. So mod of W2 square times cos square theta is going to be the base square, right? From geometry, this is mod of W1 square, right? So combining geometry of right angle triangles, a little bit of trigonometry, and our knowledge of complex numbers gives us this real part of W1 into W2 conjugate is equal to mod of W1 square, right? So I hope you have understood what we did here. The first part of the problem was doing rotation theorem to get one of the options. And the second part of the problem is to use the result that we got from there and combine the triangle information that we have. The sides of the triangle are basically mod W2, mod W1, and mod of W2 minus W1. So from there, we can easily do this basic geometry and write W1 by W2 as 1 by 1 minus I tan theta. And after that, the question is super easy and we get the answer, mod of W1 square. So the correct answers in this question are A and B. If you are not sure of how we solved this, go through the solution once again, try it out yourself, draw the figure. It should be pretty clear. And if you're stuck on rotation theorem, I would recommend watching some other videos on my channel where I have discussed it in more detail, right? There are more than 20 complex number videos on the channel, I think. And 5 of them at least are on geometry. So you should go through those and that will help you. That's it for this video, and I'll see you next time with the next question.